Right, section 6.1, properties of exponents. Okay. So this video is going to be divided into 3 parts, so this is part 1. Okay. So this section is talking about exponents. So first we need to discuss what an exponent is. An exponent is simply just a way to write repeated multiplication. Okay. So when I have multiplication happening multiple times, for example, 3 times 3. I'm multiplying 3 2 times, so I can write that as 3 is my base, it's the number I'm multiplying, and the 2 tells me how many times I'm multiplying it. Okay. So if I had 5 times 5 times 5, here I'm multiplying 5. This is what we call the base. That is the number being multiplied. And then I would put a 3. This number here is what we call the exponent. And that tells us the number of times we multiply it. Okay. So you've probably dealt with exponents before. So then 3 to the second is 3 times 3, which is 9. So 3 to the second is the same as 9. So if I needed to figure out, well, what's 4 to the 4th power? I would need to multiply 4 times 4 times 4 times 4. So I multiply 4 times 4, which is 16. Multiply by 4 again, which is 64. And multiply by the last 4, which is 256, I believe. Okay. So it's multiplying. It's repeated multiplication. Just like multiplication is repeated addition, exponents are repeated multiplication. Okay. So now we're going to jump into probably a few new shortcuts. Okay, these are shortcut rules or rules that we use. We'll explain where the rules come from later on in part 2. But for now, we're just going to know them as rules. The first rule is anything to the 0 power. Okay, any number, any base to the 0 power is always equal to 1. Okay. Okay, so what this means is if I have 4 to the 0 power, that's always going to be 1. We'll discuss in the next video why this works, but anything to the 0 power. So I could have 342 to the 0 power is 1. Anything to the 0 power is 1. Okay. But 0 to the 0 power is undefined. Okay. We can't actually take 0 to the 0 power. So your base has to be non-zero. Okay. So anything to the 0 power is 1. Okay. So if we come down here and do this very short example, evaluate each expression, 6.7 to the 0 power is 1. Now you could make more work for yourself. We could bring up a calculator and take 6.7 to the 0 power. I'm going to need my keyboard. And Desmos 60 will give you 1. Your graphing calculator will also give you 1. Hey, but why go through the work of grabbing a calculator when I know that's just to 1? Okay. All right, now the next rule is a negative exponent. Any integer to the negative exponent, so any base to a negative exponent is equal to the reciprocal. What this negative exponent does, whenever I see this negative exponent, I think reciprocal. So it's going to take the reciprocal, meaning it's going to take and give me, instead of a to the negative n, it's going to give me 1 over a to the n, positive n. So it took the reciprocal of a to the n. So we get 1 over a to the n. For example, 4 to the negative 2 is equal to 1 over 4 to the second. 4 to the second is 4 times 4 is 16, so this is equivalent to 1 over 16. Okay, so these are all equal. We just don't normally we like to simplify negative exponents until we don't have a negative exponent anymore. Okay. So on this example, if we want to simplify this, we're going to need, so this negative exponent here is going to take the reciprocal of, I have -2, this is my base, and my exponent is 4, so I'm going to have the reciprocal, so 1 over -2. -2 is still my base, but now I'm going to take that to the positive 4 power. So now I need to simplify that. How do I figure out what -2 to the 4th is? Multiply -2 4 times. 1, 2, 3, 4. -2 to the 4th. Well, -2 times -2 is 4. -2 times -2 is positive 4. Still a multiply, so I'm going to have 1 over, still my 1 in my numerator. 4 times 4 is 16. So -2 to the -4th is equal to 1 over 16. Okay. All right, the same holds true when you're dealing with variables. The only thing is we're going to need to know some of our fraction rules. Okay, when I'm dealing with fractions, if I'm multiplying fractions, a over b times c over d, I can write these as one single fraction, multiplying the numerators, multiplying the denominators. We're going to be using this quite a bit, but kind of going backwards to help us work the problem. What I mean by that is I'm going to rewrite this and break it all up into its pieces. The numerator is 4 times x to the 0. So I'm going to write that as 4 times x to the 0. And then here I've got a y to the -3 in the denominator. That's in the denominator, so we can think of it as 1 over y to the -3 multiplied. Because if I multiply this whole guy out, if I multiply this out, I'm going to get back to here. But our reason for breaking it up is now we can do each piece. So I've got a 4. X to the 0 here is just 1. 1 over y to the -3, I need to, this negative exponent is going to reciprocal. So since it's in the denominator, it's going to move it up. So I would have y to the +3 over 1. Again, it just flips that over. And then we can multiply this all out. My denominator is 1 on all of these. So 4 times 1 times y to the 3rd. 4y to the 3rd. My denominator is 1. So we would end up writing this as just 4y to the 3rd. Okay. So we use that fraction to break it up. Okay. To make your work easier to follow, I really suggest when doing this on paper that you have the numerator and denominator on separate lines of the paper. So that's how my lined paper would look. Okay. So I keep my fractions numerator on one line, denominator on the second line, instead of trying to squeeze them in to one single line of paper. Okay. All right, now we have some your turn problems. Okay, so instead of doing these problems, okay, you are going to go to Big Ideas Online. The link is in Schoology, and you're going to do the part 1 assignment and submit it. Okay, you need to do work on paper. Do it on paper, because you will be submitting that paper once you're done with all 3 parts. Best of luck.